if I could have your attention, please. Let's go ahead and close your Chromebooks. It's okay if you didn't finish the video. That was just an introduction and pretty much something to get you started, ready for the lesson. Okay. Alright, so we have covered section 5.1, which is translations, which is just moving something across a coordinate plane. We have talked about reflections in 5.2, which is flipping something. You can either flip it sideways, up and down, or you can flip it over a line, okay, like if you had a mirror. Okay. Now we're going to talk about rotations, and rotations is just turning something. And we're just going to do the very basic ones, okay? But before we start talking about rotations, first we need to talk about some key words. All right, it says, I can perform rotations. All right, so a rotation, like I said, is a turn. And if you would see over there on I have the definitions written down for you already on your paper. But if you look over there where that picture is on student notes, okay, I need you to label some things for me on that picture. Okay, this point P, this is known as the center of rotation. So I need you to label that point P, center of rotation. So point P is the center of rotation. And that angle, that 40-degree angle, that is the angle of rotation. So the point P is the center of rotation, and that angle 40 degrees is the angle of rotation. Okay, so let me explain to you what those mean. The center of rotation, that's, for instance, they have this flag at the end of let's say a pole. They have a pole, and at the end of it is a flag. The center of rotation is at the bottom part of the pole, and let's see, they started over here. They had the flag this way, pretend like there's a flag coming off of here. They had it this way, and they rotated it 40 degrees counterclockwise. And now the flag looks like this, and it's coming over this way, okay? This part here is the center of rotation. Now, to make it make more sense, the center of rotation can change. Okay, so I'm going to show you what a rotation would look like with this being my center of rotation. So the center of rotation means it's a fixed point. A fixed point. Fixed point means it does not move. Okay, so here's my center of rotation. Here's what it looks like whenever my center of rotation is in the middle. Notice the ruler stays in the same spot. It's just turning. Kind of like a windmill. Okay? So the center of rotation is in the middle, kind of like a windmill. Okay? Now, notice the difference. This was the center of rotation when it was in the center. Now notice when I make my center of rotation, let's say right here. What happened to the area that I covered? Yeah, it got a lot bigger. So my center of rotation, depending on where it's at, can make it change what your thing looks like. Okay? All right, so what questions do you have for me on center of rotation or on center of rotation? Okay, now let's do angle of rotation. Angle of rotation. This left 40 degrees. We know what angles are. Angles are 40 degrees. Okay, let's not lean on our hands, please. That way we're not likely to fall asleep. Okay, let's get our hands off. All right, so for an angle of rotation, you start at 0. A 90-degree rotation makes a 90-degree angle. 90-degree rotation makes a 90-degree angle. 180-degree rotation makes a 180-degree angle. And 270 makes a 270-degree angle. And then 360 is just right back at the spot. So that's the angle of rotation. Pretty simple.
I never knew.
Alright, so let's do some examples. Well, first let's go over some rules. Okay, coordinate rules for rotations about the origin. I'm only going to have you do rotations about the origin, so that way we can use these special rules every single time. And I'm only going to have you do counterclockwise, because that's when these rules work. I'm not going to have you doing a bunch of different types of rotations. These are the only ones we're going to be doing. When a point AB is rotated counterclockwise about the origin, the following are true. For a rotation of 90 degrees, AB becomes opposite of B, comma, A. Opposite of B, comma, A. So that's number one, 90-degree rotation. Opposite of B, comma, A. That's over there on number one under teacher notes. Right here. Okay, got that perfect. Okay. Now look over there and in your own words. Let's go ahead and turn back to the front page, please, so that way we know we're following along. All right, so what you need to do is put it in your own words. You know how like y equals x is b comma a? That means just flip your x and y. What does that mean? Opposite of b comma a. Say that a little bit louder. The new x, which used to be the what? The y. Okay, so here's the order that I do it in, just so I don't get confused. First, I change the sign of the y coordinate. Okay, so let's write that down for number one in your own words. Change the sign of the y coordinate. Then flip your x and y. So change the sign of y, then flip your x and y. Change the sign of y, then flip your x and y.
That rhymes. That makes everything so much easier.
So she's got bars.
All right, for what? Oops, sorry. Didn't mean to go that far.
I agree.
Okay, that's not what you need to write down.
Drink. That don't look like math. That don't look like math. Yeah. You're a beautiful man.
Okay.
Let me to the right of that.
For a rotation of 180 degrees, AB becomes opposite of A, opposite of B. So for number two, you need to write opposite of A, opposite of B, negative A, comma, negative B. And then what does that mean in your own words? Yeah, change the sign of both your x and your y. So you don't have to do any type of flipping. All you do is change the sign of x and y. Change the sign of x and y.
It's all starting to make sense now.
Just now? That made sense like 3 years ago.
Prophecies in the scrolls.
Okay. And the last one, this is the only other one we're going to do. So these are the only type of rotations we're going to do. For a rotation of 270 degrees, AB becomes B, comma, opposite of A. B, comma, opposite of A. Here's where you put the coordinates. Like that one needs to be the negative B, comma, A. Then 2 is negative A, negative B. And C is B, comma, negative A. Now, how would you put this one into words?
Change the sign of x and then you flip, or sorry,
X.
Flipping
God,
the sign.
Living.
Okay, so change the sign of your x, change the sign of your x, and then flip your x and y. Change the sign of your x, then flip your x and y.
Yeah.
Now, the reason I say change the sign first is because it can get really confusing on knowing which one to change. Because you're like, okay, am I supposed to change the x before it becomes the new y, or am I supposed to change the x after it becomes the new y, or am I supposed to change the new x? So I always change the sign first, then I flip it.
Easy.
All right, so let me show you an example. Now remember, with teacher practice, that I work the problem out myself. And you just copy down and pay attention, okay? It says graph quadrilateral RSTU with those coordinates, and then rotate the quadrilateral 270 degrees about the origin. Okay, so first, I would go through and graph my original coordinates. All right, so if I graph my original coordinates, first is R, which is 3, 1, and now that you know about vectors, you can just treat ordered pairs like vectors. Positive 3, positive 1 means you would start at the origin and go to the right 3, up 1. 5, 1 means you go to the right 5 and up 1. T means you go to the right 5 and down 3. And U means you go to the right 2 and down 1. Then, to do the 270 degree rotation, you need the rule, okay? So I would go back and look at my rules, and my rule for the 270 degree rotation says, B, comma, opposite of A. B, comma, opposite of A. Okay, so I would write that down on my paper, B, comma, opposite of A, and that means to change the sign of X and then flip your coordinates. Change the sign of X and then flip your coordinates. All right, so R was 3, 1. Before I do anything, first thing I'm going to do is change the coordinates of X. So let's go through and change each sign for the X value. Okay, so this 3 becomes a negative 3. 5 is negative 5, negative 5, negative 2. So I changed the sign of each of my X coordinates. Okay, now that you flip the signs, or change the signs, now you can flip them. R prime becomes 1, negative 3. S prime becomes 1, negative 5. T prime becomes negative 3, negative 5. And U prime becomes negative 1, negative 2. Now that you have all your new coordinates, now I can graph my coordinates. So 1, 3 would be to the right, 1, negative 3 would be to the right 1, down 3. So there's R prime. S prime is 1, negative 5. T prime is negative 3, negative 5. And U prime is negative 1, negative 2. And there's my new figure. Notice the size and shape did not change, just its location. Okay. Now see, look what, here, this axis is your 0 axis. This axis is your 90 degree, 180, 270 degree. So it started here on 0, so there it would have been 90, 180. Notice it's on the 270 degree axis now after that center of rotation of 270 degrees.
Which one's the center?
The center of rotation, the origin right there. So it's pretty much like you took your pencil on your paper and stuck your pencil right there, and you turned your paper 270 degrees, and that's where this one would end up if you kept your pencil right there on the origin. Okay. All right. Good question. What other questions do you have for me? Question or stretching?
Stretching, I just talked.
All right, let's do another one together. Some of these you're going to have to make sure and fill in because I left out the blank, like how many degrees to do it. It says graph triangle JKL with vertices 3, 0, 4, 3, and 6, 0, and then rotate it 90 degrees about the origin. So first you need to graph JK and L. So J is 3, 0. I have a hard time remembering. 3, 0. Which axis does that go on, the X or Y? It goes on the X-axis. So plot 3, 0 on the X-axis. So there's J. K is 4, 3. And L is 6, 0. And then you draw your triangle. All right, now it says 90 degrees about the origin. So I need to know the rules for 90 degrees. Tyler, what's the rules again for 90 degrees?
I don't remember.
All right, it's over there on the front page. Look over on the front page and tell me the rules for 90 degrees.
Just negative. Negative A. Or no, positive A.
Negative B, positive A. Okay, so what did we put down that means, Daniel? Okay, so you do switch the coordinates, but do you change the sign of X or do you change the sign of Y? Y. Okay, so what we need to do is go through here on all the Y's and change their sign. Can I change the sign of a zero?
Have a negative 0.
No, so that just stays 0. This positive 3 becomes a negative 3, and this 0 stays 0. Okay? So now, for J prime, what would be my new coordinates for J prime if I switch those, Emily?
0, 3.
Awesome. What about K prime, Javier?
Negative 3.
And then what about L prime, Harrison?
Where's it'd be 0, negative 6. That would be 0, 6.
Yeah, 0, 6. Because we've already gone through. That's why I like to go through and switch the coordinates or switch the signs first. Because, like I said earlier, if I don't, I get very confused. All right, 0, 3. Would that be on the X-axis or Y-axis?
No, Y.
Okay, so there's the 3. There's J prime. K prime is negative 3, 4. So to the left 3, up 4. And L prime is 0, 6, which would also be on the Y-axis. Now, does this look like a triangle that was rotated 90 degrees?
Absolutely does.
Yeah. Okay. Now what questions do you have for me?
No problem, Marshall.
All right, we will finish up your notes tomorrow. Tomorrow you need to bring your student journal to class because we will be working out of your student journal. Put your notes in your pocket, and then you still have 4 minutes, so you can go ahead and put up your calculators, get your phones, but have a seat.
Yes, ma'am.